Let's solve part C in this video. So we change the objective function, the maximization function, into 4x plus 2y, show whether this problem now has a solution or not. Okay, so we keep all the data the same. The constraints are still the 3 constraints that we have. And recall from the previous video that we saw this is defined by these 3 lines, and the area in between them is going to be the area of possible solutions. That's what we saw in all this thing over here. It's a bit messy here, but it's the same shape as we can see, the one that we bounded. Now, with that said, if we want to maximize this new function, how we're going to do so? Well, let's suppose we give a certain value, an arbitrary value to this function. Let's say that 4x plus 2y is going to be equal to 10, for instance. 4x plus 2y is equal to 10. Well, that means we could write this as a line, right? So we're going to have 2y is equal to 10 minus 4x. Now, if we divide both sides by 2, then y is going to be equal to 10 divided by 2, which is 5, minus 4 divided by 2, which is 2. So we have 5 minus 2x. Now we can draw this line. What's that going to be? Let me just pick a color for that. For instance, this one. Well, the intercept would be 5, right? The intercept would be 5, somewhere over here. And the slope is going to be negative 2. So the slope will intersect the x-axis at the value of 2.5. So somewhere over there. It's not very accurate, but I hope you can see the point. What is the idea of this slope? Well, look, we can improve the value, right? We can raise the value by shifting the line to the right. That's what we saw in the previous 2 videos. But the question is, until what point can we shift it? Well, look, the blue line, right? The line that bounds us, that limits our area, well, also has a slope of negative 2. And the slope shows that the lines are parallel. The purple line that we're shifting right now has a slope of negative 2 because we just saw it's 5 minus 2x. The blue line has also a slope of negative 2, meaning that they are parallel to each other. The only difference is the intercept. So we can shift the line until we reach this blue line. So on this blue line, whatever combinations we can have is gonna give us the solution, because on this line we can get that maximum value. So it means we have infinitely many solutions, infinitely many combinations of x and y, because remember, x is not just 1, 2, 3, 4, 5. It could be 1.1, 1.01, 1.001, and so on. So this value over here is going to give a y value. That's going to give us a maximum solution. The next to it is going to give another y value, maximum solution, and so on, and so on. All these points over here are going to give us the solutions that we are looking for. So infinitely many solutions. Hope this makes sense. In the next video we go to part D.